Welcome back, chat. Today, we're jumping in. We're finishing this problem. Now, we've already spoke a little bit, so Rodelia, two things. First, I hope that your day is going wonderful and you guys are playing well. And second, this is a problem that we left off on yesterday. I'm going to go really quickly. Just kidding. I don't remember how to do it, but Riley and I made eye contact. Riley, if I want to plot the point 3, 8, here I am at the origin. What do I do?
3 right and 8 up.
So 1, 2, 3, 8 up. Okay, I think there's a point 3, 8. Do you guys all agree with that? Okay, I'm going to be really precise with this stuff. 3, 8. I'm now going to plot C prime, which I was given was at -8 and -3. -8, -3. Here, and I'm going to switch color for this one. Here is C prime. Now, as we go through this, you will see, and I'll show you, but I changed the way we write these problems a little bit because I use this mapping or this function notation because I think it's really nice and easy to deal with. We'll look at what it really looks like on the problems, but they're going to ask you one more additional question rather than just what line did we reflect over. Is there a rule that we can see and maybe a pattern we can pick up that shows how I go from C to C prime or D to D prime? Like if I give you a new point, you think you can tell me what it maps to? So don't write it down, but if we had, I don't know, 3, 5, what is 3, 5 going to map to? -5, -3. How did you know that? Okay. It's done it a couple times. Your homework, just so you guys are aware, it will ask for a rule. And I think you guys can see this. I'm going to use just some generic point. X, Y. If I put this on this rule, whatever it is, Elijah claims it becomes this. Do you guys agree with that? X and Y switch spots, and then they change signs. Now, honestly, part of this I don't love, but this is the way that your book presents it, so I want you to see it. I think that we run the risk of getting really confused if we use X and Y and we start writing our ordered pairs backward, like naturally. It's the same meaning, but as an alternative, if you'd rather, I think I could do it like this and not have to worry about getting confused about my ordered pairs. Like same exact meaning, it's just let's introduce two numbers A and B that aren't X and Y, we don't get goofed up. All right, here's what I want to think. When we looked at reflections the other day, and I'm going to bounce over here real quick.
If we're giving it backwards, it's just normal coordinate.
What's that?
If we're given negative B, negative A, it would just be normal.
Negative B, negative A would be normal. Yes, but you swap them and change the sign. That's all that rule tells us. Now, this is our definition that we had yesterday for reflections when we first started thinking about it. When we measure the distance from B to this line, is this the angle that I want or the line that I want? And I'll draw it up here so that everybody can see it. If I said how far is point B from that line of reflection, is it this distance?
No.
No, I mean, it is that distance, but that's a dumb way to do it. Why? How should we do it?
Just count to the line.
So if we had a graph, we could just count it. But if we don't have a graph, we just have to do this, right?
Yeah.
And it's going to form what sort of angle? A right angle, which is why we said the perpendicular distance. Now, we spoke about this. I didn't have it on this picture. You don't need to change anything about your picture. But another way we talked about this is the distance from A to the line is equal. It means that B to here is the same as here to B prime. Everybody cool with that? If I looked at those as two individual segments, could we say that those segments are, gosh, what's the word?
Parallel or equal.
Congruent. Do you guys agree that that's what it means to be the same distance? Okay, one more little question because we're going to connect this all the way back to what we're doing. If I looked at the segment B, B prime, this whole segment, what is this point representative of? The fact that it cuts it into two equal pieces.
The bisector.
It's the bisector, but as a point it has a name. The point right in the middle. It's the midpoint, isn't it?
Yeah.
Would it be the midpoint right here also?
Yeah.
It would have to be. Now, the reason, and I'm on the same page, the reason that I only told you guys we truly needed one point is because I have no idea where the reflection is. I know it's somewhere in here right now. I can see that. You might not be able to, but it is. Could we find this segment? And could we find the midpoint on this?
Yes.
So just to put these pieces together, the line that we're reflecting over has to pass through the midpoint. So if we can find the midpoint of these, it doesn't matter.
Because it'll be the same for all of them.
So it'll be a different point, but we'll get the same relationship out of it.
Same line.
So if you are a systematic thinker and you like to have step 1 do this, step 2 do this, I cannot promise I'll always do this, but here's my first challenge. Do you guys have at least C and C prime?
Yeah.
So here's what I want you guys to do with your groups. Step 1, with your neighbors, I want you to find midpoint. And we might as well plot it. That'll help us make sense of it. Find and plot the midpoint of which segment are we going to find? And it's weird, but it's C, C prime. Find and plot the midpoint of this. Now, it's been a while since we spoke midpoints. The good news is that you don't have to memorize everything. If you don't remember how to do the midpoint, how on earth could you find that? Your notes, your book, your peers. Talk it out. Check with me once you have a midpoint. If you find a midpoint and I'm busy talking with other people, I want you to, and your group, to start thinking about where do we go from here. Remember, we're trying to find the equation of a line. That's our end goal. Cool. Find me the midpoint, check with me, and then start thinking about how do we move on from there. Okay, perfect. Everybody at the exact same time just now said, take the x's and add them up and divide by 2. Take the y's, add them up, divide by 2. Cool. All right, so help me out here. The midpoint, I'm not going to name it anything. I'm going to call it M for here. What are the x's that I'm adding up? So -8 plus 3 over 2, and -3 plus 8 over 2. Okay, decisions. We're going to get a wonderful, lovely 5/2. Are we going to use that wonderful, lovely 5/2, or are we going to call it 2.5? I disagree, but we'll do it. Okay, because it's ugly, and we'll see why here in a minute. -2.5, comma 2.5. Do you guys agree with that? Okay, so I'm going to not trust it perfectly because I have to estimate it. -2.5, so 1, 2.5, 1, 2.5. I think it's about right there. And I'm going to switch color just so I can differentiate on mine. You do not have to change color and do all that stuff. There's my midpoint M at -2.5, comma 2.5. Now, why did I make us find this midpoint? Like, what was the point of it? This isn't a midpoint problem. The line that I reflect over must run through that point. It doesn't matter if I did C and C prime, or E and E prime, or D and D prime. The midpoint is going to be on, all 3 midpoints are on the same line. Now, we're going to use that to our advantage. There's a few ways that we can do this problem. What is the end goal? Like, what are we actually trying to find here? When I say find the line, what do you mean? Like, what do I mean by that? Yes, we're looking for the line of reflection, but we're looking for, as Honor said, the equation of the line. Okay, it's going to be y equals something out of this. Okay, so right now, all I know is that my line, whatever we're reflecting over, runs through this point. Okay, is there anything else that we know about it?
Perpendicular to the line C, or the segment C, C prime.
So if we draw this segment, and can you guys see that? It's very faint on my screen. That really faint line. I know that the line of reflection is going to be at a right angle with this. It's going to be perpendicular. It has to happen because we measure that distance perpendicularly. Could we find the slope somehow? Could you tell me the slope of C, C prime? And then we'll use that. So we're going to call this, if we want this systematic way, step 2. And we're going to make it so you can actually read it. Maybe. Step 2. Bless you. I want you to find 2 things for me. Bless you. We're going to find the slope M for C, C prime, and the slope M of the, we don't have a good way to write this. I'm just going to say the slope of the reflection line. Okay. With the fact that they are what to each other?
Perpendicular.
Perpendicular. So check it out. We're putting all these pieces that we've seen all throughout the year together right here, right now. Cool. Find me the slope of C, C prime, and find me the slope of the line that's perpendicular to it. Cool.
So M reflection.
The M sub reflection. Or if you wanted to name that line of reflection line something, it'd be easier to write. Cool. You're finding me 2 slopes. Do C, C prime first. That's cool. I think it's 1. I'm going to verify. When I find, it's definitely not 6, 7. Okay.
7 minus 6 is 1.
When we do this, check it out. I'm going to use C and C prime. 8 minus -3. That's going to be the first part. 8 minus is not 5, I don't think. Over 3 minus negative 8 is what matches up. Plus 11. 11. And it's a 1. Okay. We know that this light blue line right here had a slope of 1. Now, we don't really care about the blue line itself other than we wanted to find the slope of our new line. Alternatively, could we have found the midpoint between E and E prime? And then just use those 2 points?
Yeah.
We could have, but I think it's easier to do it here than it is to find a whole other midpoint. Okay. Once we have this, it's 1. That looks like a perpendicular. It's a 1. How do you get from this slope, how do you find the perpendicular?
The opposite.
The opposite. Opposite, there's one more word. Reciprocal, or the woe, if you will. So here we go. 1 is 1 over 1. Flip it. It's still 1 over 1. And negative, because we changed the sign, the opposite. So from here, I'm just going to make a note. Opposite reciprocal. It means that we now know the slope of our reflection line is a negative 1. Have I lost anybody along the way here? Cool. All right. That was, hold on.
I don't know why I like
Alright.
I'm here.
goosebumps.
So now what?
Um,
We have a slope. What else do we have? Gosh, if only there was something to do if we knew a point and a slope. Holy point slope. All right. Well, that's all fine and dandy, but I don't remember it either. Right? Okay.
Minus y1 is equal to m parentheses x minus x1.
Step 3. Point slope. That's all I'm going to put. We found a point. We found a slope. Let's use it. And Adeline knows it. Awesome. Who else can tell me point slope without checking your notes?
y minus y1
Okay, I'm good with it. Y minus y1
equals m x and x1.
when you say and.
Minus
All right. So, help me out here. We already know that the slope that I'm going to plug in here is what?
Negative 1.
-1. If only I knew a y1 and an x1 to plug in.
8
Careful.
negative
What line does my reflection run through? Or which point, I'm sorry?
negative 2.5.
This is the only one that it runs through, right? It doesn't run through here. That would give me very different points. It doesn't run through down here. It is that midpoint, and that's why we found that midpoint. So, y, and I already forgot, through what? 2.5, negative 2.5? That's backward.
Negative 2.55.
So this should be minus 2.5. Is that correct? Equals m times x minus a negative 2.5? Minus a negative, what happens?
Positive.
Okay. All right. Are we done?
Now,
Why?
you need to graph it.
Do we? What were we asked to do? Which line did we reflect over? Did we just find the equation of a line? We're done. Now, it is a good idea. You guys probably don't feel comfortable because if you think of an equation of a line, nobody ever stops you, right? What do you want me to do? And you probably will do on your own. Okay, let's get it to y equals mx plus b and c. Well, we will take the time to graph it. Let's just verify that it's believable. Okay, how do I do this? What would you have me do? Okay, so y minus 2.5 equals negative 1 times x.
Negative 1x.
Negative x. And this one? Okay, and now what? Plus 2.5. And when I add 2.5 to each side of this equation, like, that's not 2.5. Weird. Something's gone. It's just negative x. Okay. Now, when we draw the line y equals negative x, we're going to check to see if that really makes sense. Okay. The line y equals negative x, if that doesn't mean a ton to you right now, my hope is it will once we talk about it, but we have to dig deep back into that old algebra idea. If I wanted to graph negative x, it means that what's the y-intercept of that line? 0. So I'm going to start at the origin. While I could start here, the origin is nice. What's the slope of negative 1 tell me to do? Up 1? Right 1? Positive and negative, or negative and positive, however you want to think about it. I'll go up 1, left 1. When I draw the line, and I'm going to do a couple of them so I can get a straighter line. I know it would be here and here. Does that to you if we just zoom out just a skosh, or up rather, does that look like those points did indeed reflect over that line? Yeah. If I wanted to draw all 3 points and see the reflection with a triangle instead, do you think it would still look like a reflection? It is going to look even more like a reflection at that point in time. Adeline, I think you have a question somewhere. Okay, we'll have time to chat in just a moment. Okay, looking at this question, it puts a lot of different pieces together. If you can break it down into its smaller pieces, the problem itself, much like a lot of the things that we do, I don't think is wildly difficult. What is difficult, and rightfully so, is trying to recall all this stuff. Math is unique in that regard. If I know nothing about the Civil War, can I still know a lot about World War II and be really knowledgeable about it? I think so. If I know nothing about lines of functions, can I really do anything more involving that idea whatsoever? Math builds so much on itself. There's a lot going on here. It's fair if you're struggling with it. That makes sense. There's a lot of pieces to put together. When we see these, and I'm going to give you guys time to get practice, rather than us just doing an example together, I think we're just as valuable if I give you an assignment on the homework and I say, show me that you can do this, because we're going to have time to work on this. However, I want to make sure that you guys see the way I present these questions is not exactly the same as the way that your book presents these questions. Okay, let's check this out real quick. Anybody in here play pool? Pool? Okay. We're not going to do this whole problem because we don't get a whole lot of additional math, but I'm going to show you. Anybody really good at bank shots? Where I hit the ball off of the rail and have it bounce. So like, let's say, why would I do that? Why don't I just draw it here? If we have a pool table, and then let's say, and we'll actually just talk about this real quick. You don't have to draw this, but I need your eyes and ears open, okay? All right, let's say I'm trying to make the 8 ball in this pocket eventually. And here, you know what? I'm going to make it in this pocket. Here it is. And unfortunately, the 1 ball is stuck right there, so I can't shoot in that pocket. And my cue ball is right here. Like, there's a way that I can hit this such that it does this, and it bounces down and then up here, right? Like, I can see that exists. Now, when you guys encounter this situation in a game of pool, you probably don't think, oh man, thank goodness Mr. Holloway taught me about geometric transformations or isometries in geometry the other day. Or you do, or every single time. Maybe more natural for you to think that every single time. Now, it turns out that it is exactly this idea that we're talking about right now. And obviously, reflections look different than bounces. But if you've ever seen light reflect or anything, a reflection, it's literally just the light bouncing back out. Okay, as we look at this, if you wanted to make a robot that could do this, because it's hard to actually do this in your head, I think that I can imagine this as a line, right? The side of the pool table. Could I reflect this point down to here? Now, when I do it, and that's not going to be perfect, but I think it'd be roughly there. Do you guys agree with it? Is that way off? Do I need to go up or down if I'm trying to reflect this point across this line? It's good enough? Okay. Now, I'm going to teach you a phrase that I didn't really understand what it meant until probably my mid-20s. If somebody says they're going to take a beeline, do you know what that means? Yeah, like I'm going to make a beeline to my desk. If I do that, I'm going to have to walk over Prime, probably over Michelle a little bit. Because a beeline is a straight path. Do you know why we call it a beeline? Bees. Like the bugs, bees. If there's a flower back there, I'm not going to do this, right? I want to save energy, save space. A bee flies in a straight line. It's called a beeline, like B-E-E, not the letter B. I was embarrassingly old when I learned that and discovered that and had that realization. Cool. Seems random. Why am I talking about beelines? Hey, if I can see where this reflection is, and Nelson, you got it spot on. My reflection's not perfect. It's also not a square, so that makes sense. If I go through there, I can line this up, and obviously I just eyeballed it so it didn't work. I was off a little bit. If I could find this spot, and I can make it so that I hit it so it hits right at that spot or through this spot, and see I want to hit here, I can now work out the angles because it's going to come in and out at the exact same angle, and it will go in. Now, to show you this, because I just tried to freehand this, and that was a terrible idea because I'm a learning artist. That's me saying I'm bad at drawing stuff, but I don't think I'm really bad. I just don't think I have the practice. Okay, just to show you this demonstration with a much better picture. Okay, check it out. Here's this person. Exact same thing. I don't know why I didn't do this to start with. We'll focus. We'll focus again. All right. They are trying to bank a ball somewhere. Now, they're trying to hit this. So notice, they want to hit this ball, they reflect it. They then aim the straight shot up to it, and check it out. We are going to get the perfect reflection to hit that ball. When you're trying to line up your shots in the future, this is a good way to think about it. You're never going to have a physical object to like make that perfect straight shot for, but you probably think something along these lines. Hopefully now you're a little bit better at pool because you have some guided thought to do. Okay. For this evening, and starting right now, my goal and my hope is that you won't have homework over the weekend in the end. Because you get quite a bit of time in class to work on the following. So, what I want you guys to do, what?
Do we have to draw the line system?
Do we have to what?
Draw the actual point through it, or like the...
It's a good check. If you didn't hear Adeline's question, Adeline said, do I actually have to draw this line? And looking at this one. You don't physically have to draw it unless you're specifically asked to. Does it do a good job of convincing me that my reflection's been good?
Yeah.
Like, it's helpful to check your answer. If you're asked to draw it, definitely draw it. But if it's not specified and it just says what line does it reflect over, I'm cool with it.
Where do we draw it over at, though?
What do you mean?
Like on here, where do we draw
I would draw the exact green line that I did. Through this point with a slope of 1 or -1. We'll clear up because you had some questions, I think. Okay. All right. Your homework, or classwork rather, right now is right here. We did not start 3.2 yet. We might. We got a lot of time in here. But if you give me something interesting to talk about after we're done with the homework, I could probably be convinced. I want you guys to work through 3.1. So initially I had the 10th, and I don't know why. The 13th. Okay. If I will. I'm going to put the right date. Okay. I'm pretty good at making up problems just kind of on the fly. And I'm really good at making up problems that don't have really nice answers on the fly specifically. We have 30 minutes right now to work on stuff. If we get 10 minutes in and it seems like people aren't working, I'm going to spend a minute or two to write a few problems that maybe don't have nice answers. For what?
Quiz.
A quiz. I don't love the idea of you guys looking, or me using even, a quiz as punishment. But if you get time to work on stuff, work on stuff. Okay, I'm here to answer questions. Your peers are here to answer questions. Jonah, I'm terribly thirsty. Will you go get me a drink? Like, I'm just dying over here. I'm parched. Cool. All right. You guys do it to it. If we finish early and we have something cool to chat about, I'm good with it. If you guys finish early and we just want to start the next section, I'm also cool with it. Cool. You will likely finish. Baller. Do it to it. If you're struggling with number 19, here's number 20. Here's the directions. I did not even think about recording. They give us all this information. Now, all they're asking for are the coordinates after we reflect over whatever. So check it out. When I do this problem, or 19 or 21, this is what I would have if I were you. I know that for this triangle, A is the point 9, -3. I know that B, they tell me, is the point 6, 4. And that C is the point -1, -5. Okay. Now, they then say, find me the new coordinates. And here we go. I'm doing my mapping or my function notation. And then I like to do the following. We're reflecting over what on number 20? Yep. On 20, it's the y-axis. On number 19, if you're doing 19 at the same time, it's the x-axis. You can tell me what's happening here. And the reason that I'm recommending this is because if later we have to rotate it afterward, maybe I want to know that this is my y-axis, and then I rotate it afterward. I can keep track of stuff. So you guys help me out real quick. I know you did 19, and this is 20. If I'm going over the y-axis, a point x comma y, or I'll use AB here. It's whichever works. If I'm doing AB and I reflect it over the y-axis, what changes, x or y?
Y.
The y value changes if we go over the y-axis?
Or the X changes. It just
The x changes. Now notice, I'm doing 20, not 19, right? You guys don't do this problem, but I know that this is how this rule works. Okay, knowing this, can I apply that rule to these points? Okay, we just changed this sign. This one stays the same, this one stays. What? Weird. -9, comma, -3. B prime on number 20. Again, not 19, not the one you did. -6, 4. And C prime? 1, -5. Now, the only part where this gets weird and where people will naturally, does that seem much easier than you thought? Okay, maybe not. I would encourage this notation. It's like when you get a quiz or a test from me and I say do this, I'm going to give you this is where, like, when you look at the problem, it's going to say write your ordered pairs here. This is a notation that I force you to use on a test, just so you're aware. Okay, 21. RM. What the heck is RM? So I understand that. You're going to think slope because M is typically slope, but I'm going to read this problem again. M is the equation x equals -5. It's the vertical line. This is just reflect over the vertical line at x equals -5. You will, if you need to draw it, it'll probably help because there is a way to make a rule out of it, but we aren't going to do what's the rule if it's x equals 1 and 2 and 3. We're not going to do infinitely many of them. If you sketch the line x equals -5 and one of these points, you can likely work out a rule for it. That makes sense. I guess we'll find out. I want you guys to try 19 and 21, and if it doesn't make sense, I'm here. What's up? So again, for 21, the line M is written right here. M is the line with this equation, which means if I were to reflect this, I'll show you. I'll do 21A for you. And sorry, I'll give this right back to you. I'm sorry. Okay, on 21, if we're looking at point A, help me out here. We're reflecting over x equals -5. There's -5. We're going to reflect over this line. Okay, this is number 21, the very first part, and I'm even going to help you and show you that we don't really have to draw them all. I'm going to plot 9, gross. I'm going to plot C, that's easier. C is at the point -1, -5. I don't know, about there. -1, -5. If I reflected this, what's this distance over here? From -5 to -1. Could I go 4 this way? And what y value would I be at? Or sorry, x. So do you agree that if we reflected point C over the line x equals -5, it would now be -9, comma. Did the y value change if it's just over that line? Nope, it's -9, -5. And terrible choice by me because it happens to live right in the middle of my point. If I see that this is the line I'm reflecting over, just like we do with the x-axis, I think it just winds up over here, right? Where the distance stays the same. There's a way to work out this rule. I'm not going to do the rule for every number. Of course, we can't. We don't have time. But I trust that you guys can either work out the rule or you can see it on the graph. Cool. I'm going to let you guys keep working. Remember, I'm here to answer questions. Akis, did that answer your question? Okay. So here in a minute, when somebody tries to ask me, what about line G? Read the directions. They give you what line G is. Cool. All right. Do it to it.